Welcome to this next talk is by Martin Golasowski and Mohamad Hayek well, they're two different places. And this is actually the Best Student Technology Award winner this year. So congratulations to both of you. We sent you a large cash sum for your victory. This is a talk from them about a transnational data system for HPC cloud computing workflows based on IRODS and EUDAT. And this is the LEXIS project. Go for it, Martin.
Okay, thank you, Ralph, for the mic. So hello, everyone. My name is Martin, and together with my colleague Mohamad, we will present you the LEXIS project and the way how we use IRODS basically to implement the workflow orchestration platform for HPC and cloud and big data. So first, something about the LEXIS project. So we are both of us are from Europe. This is a European project. So if you are familiar with Horizon 2020 program, this is one of those projects. It started in January 2019, and it is supposed to finish in this December. So we are in the, let's say, last 6 months of the project at the moment. We have 18 partners. You can see the consortium here. It's basically a group which consists of the research centers, technology providers, developers, and so on. And also, this is the green portion. And the blue portion here are our use cases. So we have 2 use cases from the, let's say, the research domain. We have weather and climate, earthquake and tsunami. And we have 1 use case, which is from the industry domain, and I will talk about them later. So the overall funding from the European Union is around 14 million euro, and we have 18 partners in total. So first, something about the challenges we would like to tackle basically in this project. So we are hoping to develop a platform which will allow orchestration over complex workflows over cloud and HPC resources, which are geographically distributed. And for that, we would like to use a common, let's say, common data infrastructure or common data API, and we are using IRODS for that. And the whole platform will be able to handle the movement of the data between the different resources across Europe, across the connected centers, and we'll provide the REST-based APIs. So we are taking some inspiration from cloud, and we are also focusing on the metadata management solution because we are dealing with a lot of research data, and the data has to be published. So we have to follow this FAIR principle, of course. And IRODS is helping us with that, and we are using also the UGM technologies which are built on top of IRODS. And as for the data sharing between the resources, Mohamad will talk about that later. We are using the burst buffer nodes and FPGA cards to help with some of the I/O tasks that are like encryption and compression. So just to give you an overview, without putting much focus on what about the internals of the project. So we are dealing with distributed simulations which are handling big data, terabytes, say. We have a unified AI. We have the LEXIS project has a single IDP provider based on Keycloak, OpenID, JWE tokens. And we have to take care of data curation, management, sharing, and so on. And for that, we are using the IRODS, and this is what we will focus in this talk. And for the workflow orchestration, we are using the York orchestrator, which is developed by the Atos company, one of our partners, and also HPE middleware, which is basically a REST-based API for various HPC schedulers, and this is developed by us, by IT for Innovations. And we also have a billing solution. So we like to generate the invoice. If someone consumes some resources in our platform, he or she will get a invoice, hopefully. And the focus of this is basically to provide a platform which makes it easier for the industry and science to use powerful HPC and cloud resources, basically the HPC as a service. So something to focus on the data, how we are handling the data in the platform. This is a scheme of how we are connecting different HPC centers together. You can see here on the bottom that we are using IRODS and one other API to connect the data, the centers to each other. You can see that two main centers, this is IT for Innovations, this is where I'm from, this is the National Supercomputing Center of the Czech Republic. And the other center is the LRZ, which is the supercomputing center based in Germany, in Garching. And we have a couple more other providers which are not providing, let's say, computational resources, but only data through some other APIs or the IRODS. That depends. So thanks to IRODS, we can federate our zones between each other and share the data easily. So just to give you a overview of what kind of storage we are handling in the project. So we are trying to handle all the tiers which are now in the high performance computing infrastructure and cloud as well. Here the red one in the bottom is the fastest one, the NVMe, these are the NVMEs and the NVD memories and so on. Then it goes higher up through the parallel file systems connected to the HPC clusters, NFS shares, POSIX and so on, up to the object and block storage like Ceph and so on. This is something which is handled by the special staging APIs, which will be described by my colleague Mohamad later in the second half of the talk. And we are using IRODS basically on the highest level here to move the data between the different centers, as I said before, using the UGM technologies. About the use cases, so we are testing this platform by those three use cases. So we have aeronautics use case, which is, let's say, the classical HPC case, which runs the CFD simulations of jet engines and also some gearbox simulations and so on. They are handling a lot of data also because of the checkpoints they are generating in their software and so on. And they are using 3D visualization heavily. So we have to move the data between cloud and HPC in order to, or between HPC and cloud in order to do that. Then we have earthquake and tsunami use case, and this is a kind of a special type of workflow because it's triggered by an earthquake, which can happen somewhere in the world, and then this workflow will compute simulation of a possible tsunami and possible danger posed by the tsunami by this event. And then we have a weather and climate use case, and this is, let's say, more classical use case coming from the climate modeling and so on. And those are also handling huge data within the HPC clusters, and they are using a lot of post-processing to create visualizations of their simulations. Beside that, we also have a LEXIS open call. So we are open for collaborators from industry and academia, so they can test the platform by providing their workflow for us. About user experience, as I said before, we are trying to provide REST APIs for all of our modules. Basically, we are developing here in the project, and we built also a web-based portal on top of those APIs in order to provide the users easy way to manage their data, to manage their workflows, to execute their workflows, and so on, to view how many resources they consume, and so on. So this is also part of the project. So now I will go quickly. I will start with the DDI, with some internals and how we are how we integrated IRODS in the DDI. So basically, the DDI is the integral part of the platform. It's here in the bottom. It shares a common AI, and the portal data workflows and visualization relies on the DDI. Also, the monitoring system has to be connected to it, and in order to get proper performance metrics and also some auditing trail the platform users and basically for the platform operation. So the main use case for IRODS in our case is the replication of the data using EUDAT B2Safe service, which obtains PID handle for a particular data set in IRODS and is able to move it basically between two federated IRODS zones. So this is those two pictures describe the two HPC centers, LRZ and IT4I. Each of us have our own IRODS zone, and we are federated together, and we can replicate the data using the B2Safe service, which also provides a tracking of the replicas in the different zones. So this was about the overview how we are using IRODS in our solution, and now something about a few, let's say, problems we've encountered over the period when we were integrated the IRODS in our platform. So as I said before, LEXIS has its own IDP, its own identity, and it's OpenID. It's a key cloak based provider. And it uses JWT tokens for everything. And you can see here how it looks like in the practice. So we basically took together, we took the existing solution, which was available on the internet, on the GitHub. We are using the IRODS auth plugin OpenID, which is installed on the ICAT server and also on the IRODS client. We are using heavily the Python IRODS client, which is used by the APIs. And also we are using the authentication microservice, which serves as a broker between the key cloak provider itself and the IRODS authentication protocol. But it seems that there is a problem because our tokens are kind of big because they contain a lot of information about the permissions and association with the different projects and organization and so on. And it appears that the JW token is sent in the username field by the IRODS authentication protocol, and the field is only 124 bytes big, and our tokens are bigger than that, so it's too big to fit inside. We got some errors when we used plain JW tokens. So our solution to that, this was done mainly by our colleague Rubén. And our solution was basically to use hashes of the token instead of the full token in order to get an authentication between IRODS and the key cloak. So the only place when the JW token is actually used is the communication between the authentication microservice, which is a Django application running somewhere close to the infrastructure, and the key cloak itself. And everywhere else we are using hashes. And the thing is that in order to do it that way, we had to patch basically all of those services. We had to patch the authentication plugin, we had to patch the Python IRODS client, and also the authentication microservice in order to accept hashes instead of the full tokens. And all of that is available here on our GitHub, and I think that we already submitted a few pull requests to the official IRODS organization on GitHub. Okay, so that's all from my side. Now I will pass the mic to my colleague Mohamad, and he will tell you something about how we are using IRODS in high availability, and also what kind of APIs we implemented in the platform.
Thank you, Martin. Yeah, so in this section, I will be talking about our IRODS setup. So although we have the data replicated between LRZ and IT4I, we wanted to have at each center a highly available setup of IRODS. So for that, we used the HERS, the highly available IRODS system, and we deployed 2 instances of the ICAT server. And in front of these 2 instances, we have an instance of HA proxy, but we had some problems when we refer to these 3 instances by the IRODS server instance. And yeah, especially in IRODS 4.2.8, we see a lot of errors on our ROD server log, but these errors don't seem to affect the performance in IRODS. We also faced some errors when trying to execute some IRODS rule, and I guess for that we have already a GitHub issue opened. And after we have secured the IRODS in a highly available mode, it was the time to think about the ICAT database, because even if we have 2 instances of the ICAT server, if the ICAT database is down, then both of these ICAT servers are down. And for that, we tried to deploy 2 instances of the Postgres. One is in the master mod, and the second one is in the slave mod, so primary, secondary mod. And the primary one is allowed to read and write, and the secondary one is only in the read. And the synchronization between the 2 instances happened through the replication manager. In front of these 2 instances, we have a third instance which contains a PG pool, and PG pool manages the failover in both instances. So in case the primary database instance is down, then PG pool will trigger a failover mechanism that will set the secondary as the new primary, and then allow the new primary to read and write. So in our setup, if we have one of the Postgres database down, then our IROD setup still works. If we have one of our ICAT server down, then it still works. And of course, if we have one ICAT server down and one Postgres server down, then still our system would work. And now I will talk about the integration with EUDAT services. So I think in our proposal, we wanted to have a look at the different EUDAT services and try to see what services we could integrate in LEXIS. So we had the look at services like B2Save, which basically is used for mirroring of data between different IROD zones. We looked into the V2 handle that provide the persistent identifier. And this was specifically important for us because we wanted to adhere to the fair data principle. We also had a look at the V2 stage, which basically adds a good FTP server on top of IRODS and allows for high performance data movement. We had also a look at the services like V2 find, V2 access, and V2 drop. But yeah, as of now, we are only using the first 3 services. But we might consider the other services for later. In LEXIS, as I mentioned, we care about the FAIR principles, and for that we have the certain care for metadata and PIDs. So for the metadata in LEXIS, we are storing all the metadata in an attribute value units in IRODS. And for that, we are using a scheme similar to DataSite. And we are using V2 handle to assign persistent identifier to data. And we might later, as I said, consider V2 find for making the data public. So as I mentioned, for V2 handle, we deployed an instance of the handle system, and we acquired our own prefix so that we can assign handles persistent identifier to our data. And these persistent identifiers are also saved in IRODS as metadata. For V2 safe, we deployed V2 safe at both center, and we are basically using it to replicate the data between the centers. And the V2 safe uses the V2 handle to assign persistent identifier to the parent data in case they don't have the persistent identifier yet. And it keeps tracks of the replica by also putting in the metadata the PIDs of the parents or the children data set. We are also using the V2 stage, which is adding a grid FTP on top of IRODS. And we have some use cases where users transfer data to IRODS via V2 stage. And this is mainly when we are dealing with big data. And on top of these P2 services, we are also having our custom APIs that is exploited by the portal and the LEXIS orchestrator. We have first the LEXIS IRODS API. This IRODS API is used mainly by the portal to create and delete users, to create project collection across the federated zone and set the ACLs for this project. And we also have the token services where a user could log in and get the token, which is already could be used to access IRODS. And for that, as Martin mentioned, we had to fork the IRODS Python client to support the OpenID authentication. And yes, here we have one of our big APIs, the LEXIS Staging API. The idea behind the Staging API is to allow users to stage data between different components in the LEXIS platform. So we have the IRODS. So for the federation, we are moving data via B2Safe, but in case the user wants to move data from IRODS to the cloud at LRZ or IT4I, or the user wants to move data from IRODS to HPC, then this is also happened via the Staging API, and is the same between the cloud and HPC. And for that, we authenticate this API with the LEXIS AAI to make sure that the user has the right to access the data and the source and to write the data on the target. And we use the HIPI middleware to authenticate the requests that are going to the HPC. Since these data transfer could take some time, we deployed a queuing system, and we use Celery and RabbitMQ for asynchronous requests. So a user will send the post request with certain information, such as the source system, the path of the data, and the target system. And the user will get back a request ID, which he can use to track the status of the data transfer. And here's a diagram of our setup. We have the Django API, which is connected to the Celery worker. For example, if the API is deployed at LRZ, then you have a Celery worker at LRZ connected to the RabbitMQ server and the Postgres database for the result backend. And we have the client Celery worker that would run at the opposite center. And depending on where the source and the target of the request, the API will push the task either to the first worker or the second worker. And lately, we developed the Encryption and Compression API. These are also both RESTful API, and we took advantage of our experience with Celery and RabbitMQ to set up another asynchronous API. So for encryption, we had some use cases where the users want to have their data encrypted in IRODS, and this was not possible to do when the data are at IRODS. So for that, before the data moves to IRODS, we are encrypting the data on a dedicated machine with the high resources and NVMe disk. And this is available at each of the centers involved. For compression, we realized that staging of big data with a lot of small files causes really slow data transfer rate. So we thought about compressing the data before moving it to IRODS, and it actually increased the transfer rate by up to 12 times. And since, of course, compressing might take some time, we also are using a dedicated machine with high resources that is actually giving good rate with compression. So for example, we could compress an 8 gigabyte folder with a lot of small files in around 15 seconds. And this is also available at each center. And in conclusion, we had a very good experience using IRODS to federate the infrastructure at both centers. We have tested multiple setup of IRODS, and yeah, we decided to go for the high availability deployment. The use of EUDAT services was very important to us to achieve the fair data principle. And the IRODS Python client was very important for us when developing connectors between the LEXIS distributed data infrastructure and orchestrator and portal. The OpenID was an obstacle for us at the beginning of the project, and we hope that in the 4.3 version of IRODS we could have a native implementation that will make it easier for us to use. Thank you very much for listening to us, and we are happy to answer your questions.
Oh, great, thank you. It's impressive. It's a lot of work. I know you guys have been working on this for a couple of years. So it's great to see it all in one place. Yeah, the 4.3 authentication issue should mean that you don't have to have a fork anymore. That's the goal. And obviously we want you in the room as we're making those decisions to see how it all works and test drive it before it gets out the door. We have a question about PG pool in production. What happens during failover and how quick is it? Or, do you see dropped things? And then how does it handle existing database connections? I imagine the answer to that is it doesn't, because IRODS doesn't retry things.
Yeah, exactly. I mean, the chance, so the failover mechanism happens quickly, the chance that some connections might drop, yeah, is there.
Right, okay. And then at that point, we assume that the application doing the work has some kind of retry as well, perhaps, depending on.
Yeah.
Okay. And John Constable says, is the PG pool server a single point of failure itself? Is there just one PG pool? Same as the HA proxy, I guess,
Yeah, exactly. Yeah, of course, if the PG pool machine is down, then yeah. And
okay.
both the Postgres databases are not reachable, which is the same in an HA proxy setup.
Right. And are those machines themselves virtualized, or are those?
Yeah, they run on our VMware infrastructure.
Yeah. Okay.
It's the same for us. We are virtualizing the HA proxy, and we are using Keep Alive to move a virtual IP between the two instances.
Right. And you haven't necessarily found that those ever fall over in a way that you have to fix. I mean, obviously we all engineer things to be as good as they need to be, and maybe a little better, but.
The failover works, but the only thing that we had to fix was that initially we were using load balancing between two ICAT servers, and it wasn't working. So we are just using primary and backup, and that's it.
Oh, interesting. Okay.
Yeah, because of the sessions weren't synchronized. I can imagine.
And that's right. They're just going to whatever. Yeah, that's true.
Yeah.
That's true.
Okay.
We have one comment here that async encryption and compression is pretty cool. Would it be interesting to see how Celery was employed for comparison to the automated ingest capability? Does that sound familiar? Have you used the ingest tooling that we built?
No, not at the moment. I mean, I think that at a certain point we took a look on it, but because in the Staging API we have to support a lot of different resources, not just the IRODS.
Sure.
We have to move the data from IRODS to somewhere else, and Mohamad developed a pretty cool routing system, which essentially uses the Celery patterns to move the data around, so it can take the data from somewhere, compress them, and move them somewhere else. This is what the Celery does, basically.
That's right. Very nice. I don't see any hands up. I think that's all the questions. Right on time, guys. Excellent work. Thank you.
Thank you.
Thank you.
We'll see you soon.